Dear audience, welcome to the 6th IQM and the 2nd Guangdong Hong Kong Macau GBA Air Forum. So today I'm going to do a presentation. The topic is about the sensor technology innovation for smart environmental management. I myself is Dr. Jinan. I'm from Hong Kong University here. Now I want to give a very brief introduction about the background, why we have this emergent needs to use new technology to help improve our environmental management. As you can see from this slide, the air pollution is not standing alone. It is a very cross-disciplinary problem. When we look at the environmental quality problems, we also look at the public health issues because air pollution does impact on our public health. At the same time, in the urban cities, especially like in GBA areas, Hong Kong is an extreme example. Our urban design is very extreme. You have a lot of high-rise buildings, and as air pollution, oftentimes they are trapped inside the street canyons. And looking at energy consumption and energy, the generation, you can see the use of energy created a lot of problems too. So these are all circulated problems. When we look at air pollution, they never stand alone. And in Hong Kong especially, we do have a quite interesting urban structure. You can see from the picture right here, you have a lot of high-rise buildings in a tiny patch of land. And we have a lot of air pollution sources, and the people live in different corners. If you look at only one single site, oftentimes they don't create enough information that can be useful for people living around. So in order to get information and help protect the public health, we have to rely on different ways of doing air quality monitoring and the environmental management. So here we hope to have this paradigm change in terms of the way we understand and we monitor the environment. So the work we do here in the UST, we do the air monitoring technology innovation. And if you look at the hierarchy of different ways of monitoring the environment, you can see very traditional ways. It oftentimes relies on regulatory monitors. They are oftentimes very bulky, very expensive, and often requires professionals to operate them. At the same time, you can see in the last few years, in the last decade, this kind of low-cost sensors, the consumer-grade sensors, have become very, very popular. And they are very cheap and also small. But usually they are for family and personal usage. But when we look at the environmental management, we require high quality and reliable information of the air quality in order to make a decision. So here we work a lot about the professional sensors. In a way, we hope to have the balance between the cost and also the better quality it can achieve. We call it the professional sensing technology. And in the UST, we do different areas when we talk about the sensor technology. Mostly we look at the three different aspects. We do a lot about the science-driven, the fundamental-driven, the sensor technology innovation. We look at the sensor head development, algorithms. At the same time, we work a lot about the engineering perspective, because from the laboratory, from the theory to something that's real, that can be used, it takes more than just the science. We need engineering capabilities to work out things that can be used. We work a lot about the sensor system design and integration, etc. Last one is also important. Once we have the science-driven theories, we have engineering the systems, we have to use them. We have to use them in our real world and see how these technologies can help our smart environmental management. So we work with the government agencies, we work with industry, and used and applied the sensors in different aspects. So my talk today will focus a lot about application, how different examples we have realized in Hong Kong and in other areas, and how they can improve our environmental management. In 2015, this is the interesting example we did with the smart this standard chartered marathon. And along the marathon route, along 42 kilometers, we have set up this pollution sensor network along the marathon route, and this is 2015. And you can see early in the morning we set up this sensor network in an ad hoc basis inside the tunnels, in the high-rise the buildings, and next to the starting point. And here, when we provide information for the first time, we can actually real-time broadcast air quality information, not only to the runners, but also to the general public, to the event organizers. And when they look at the information from the roadside once they pass by, they can know immediately, next few kilometers, the air quality information is good or bad, or how they can adjust their own paces when they do these athlete spots. At the same time, the information can be broadcast along the public forum, and the people can really see the information. Now, this is the interesting first attempt when we're using sensors to help improve the coverage of air quality information. And the real-time broadcasting of this air quality can be helpful for the runners too. And later on, we move on in Hong Kong, in other cities, in Shanghai. We find out that not only the sensors can be stationary, and also they can only be not only be ad hoc basis. When we set up the sensors in different platforms, moving platforms, like the buses in Hong Kong and the taxis in Shanghai, and we can find actually the information of the air quality, they never stand still. Actually, they are mobile. They provide information in a totally different dimension. Here is it one example you can see. It's like a big data approach. We can see in a big city like Shanghai, when you have many taxis carrying the sensors with air quality information, they can really project these air quality and air pollutants along the roadway network. And also here you can see in Hong Kong, as another example, in our over 1,000 kilometers square area, you can see when we have these sensors hour by hour, they scan the entire roadway network. The air quality information can be easily differentiated. Here you can see the Kowloon Peninsula and the Hong Kong Island. You can see air pollution are oftentimes much more worse than other areas. And here, when we have this information real time and for real, and the environmental management becomes more targeted. So these are all interesting examples, and not only from this air quality information itself. If we look at the data in a different dimension, and you put the information like the traffic intensity, for example, here you can see when you put the bar chart, which is how many vehicles passing by the certain section of the street, the air quality information, you put them together, you can see they are not always connected positively. Sometimes you can see you have a huge amount of the traffic, but the air quality information may not be really high. And at the same time, you can see there are some streets with only half of this maximum here, but the air quality information, the air pollutants levels, can be even a triple, even many times compared with the other streets. So here gives interesting information using the sensors as a large data collection tool. The air quality information can be easily connected with other information. And when they combine, you can see our air pollutants may not be always linearly related to the sources. So how we can develop these cost-effective air quality management tools? This is something we continue to work on with the government. And now here we mentioned about these sensors. They are on the road and the stationary and a tripod. At the same time, we can see the sensors can also be, because they're so small, they're so light, they can also be on board of the drones these days. And here we work with the Hong Kong EPD. An interesting example, we shrink the size of the sensors into 700 grams, and we put the sensors on the drone. And the drone can fly, can hover in different places, and the air quality information from these sensors can give us a different dimension. It's not on the ground level alone. It can go also vertical. So what can we do with it? And our best example, we have used the sensors on the drone, is to use the sensors to look at the ship emissions. And here you can see an interesting example. We carry the sensors on the drone, and we fly the drone in the Hong Kong waters. And in Hong Kong and in many other port cities, we have the stricter regulation now to control the fuel quality the different ships have been using. They have to be below certain threshold. So how we can know these ships are complying with the regulations? And the traditional way is to go on board and take the fuel samples. But with the drone, with the sensors, we can make the enforcement much more easier. And here you can see the drones can fly over to the ships, and with the infrared camera you can see this plume coming out of the ships. You can see these different colors. And over there, when we scan the plume, actually we get information of the ships, the pollutants, and also the fuel sulfur content. And in the Shenzhen, we demonstrated this one in the Yantian port, and in Hong Kong, we also had a close relationship with the Hong Kong government, and see how we can make use of the new technology to help the law enforcement. And another area I want to jump over is more than just enforcement. We have a lot of keywords about the smart city and the smart lamppost. And this is an interesting example. We have the smart city environmental sensor network currently operating in Hong Kong in different corners. This is actually in the Kowloon East, and you can see with these smart sensors on the lamppost, we can provide information in a small community in a much higher dense way. And the people, when they walk by, they get a Wi-Fi information, they get pushed with this air quality information. And for sure, this one can help improve the data infrastructure of the smart city for the future. And another interesting point I want to also raise is when we talk about the enforcement, law enforcement, it's more than just the environmental management. Sometimes the EIA, environmental impact assessment, can also make use of this new information. Here you can see when we look at these tunnels, when we have air quality information in the tunnels, usually it's not so easy to get. But with the sensors, it's so easy to deploy. Within hours, we can set up this sensor network. It's interesting, good example when we set up this central Wanzai bypass. So you can see the air quality information can be easily broadcasted and compared with the nearby. So we can know is the ERA much more compliant when we have a special event with this ad hoc deployment. And not only in the tunnels with much more air quality, air pollutants driven sources, and also you can see the PTI in Hong Kong, the public transport interchanges. We also set up this sensor network with support from Hong Kong Transport Department, EMSD and EPD. And we can actually get the information from these different bus terminals. And from there, we can understand when you have a lot of buses coming by, when you have a setup of different bus stations inside the terminal, how we can improve this already bad air quality inside, how we can smartly distribute the bus stops and control the pollutants using the sensor network. And lastly, the two examples I want to give is the air quality management is talking about improved air quality in general. But how about you and me as individuals? Our personal exposure is a very important component for this air quality management, how we can improve your exposure levels. And here you can see we have, even in UST, we have developed much smaller sensor packages that can be carried with you, and you can go with the sensors. Suppose you have asthma symptoms or other respiratory issues. When you walk around in the streets, when you decide to go somewhere, and the air quality information around you becomes so important. So with this information, you can actually you can know the air quality information around you. That will help you improve your personal health too. And you can see from this example, when you look at this air quality around us, our personal exposure levels, they don't necessarily always the same as outdoor air quality. And you can see for some of the individuals, you might be exposed to air pollutants information much more worse compared with nearby stations. But if you stay in a clean room, a clean environment for a long time, even though there is a pollution episode outside in the outdoor environment, you might be protected pretty well by the filtration system, etc. So this individual exposure is becoming very important, and for the sensors, that can be very important arena for the health protection. The last one, something just interesting to show. When we care about the air quality, environmental management, oftentimes we link with health, we link with policy making. But here I want to give another example that we not only look at this health and environmental management, even in the macro environment like museums, like Last Supper, we work with Italy, the museum, and we actually set up this small sensor network inside the museum, and the purpose is also about the environmental management, but it's about the building environmental management, how we can make use of the sensors and try to protect these acidic gases, how they can damage the paintings. And these are all the examples we find out when we look at the sensor technology in the past decades. Their developments have helped us improve this environmental in a much more smarter way. Thank you.